Here's another vector that we need to break into components. Remember that you have to pay attention to the positive directions. Give that a shot. Let's draw the right triangle that will show the components. We want to include the angle that we were given and use the overall vector as the hypotenuse and have legs that are parallel to the axes. We have to draw arrows on the legs. The overall vector was pointing down and to the right. Down and to the right. Now this is delta r. Do you remember what delta r stands for? I think we saw that in the last problem, right? Displacement. Well, remember what the symbol is for the x displacement. Delta x. You might have thought it would be delta r sub x, but no. That turns out not to be the right symbol. This is the symbol for the x displacement. So here's the y displacement. This is the info we were given. This is the angle that we're focusing on. Let's label our hypotenuse and our adjacent side, adjacent to the asterisk, and our opposite side. To find the adjacent side, we use the hypotenuse and cut. The adjacent side comes from the cosine. Cosine of 60 here. Our adjacent side is delta x. But I know you didn't write down delta x, did you? You wrote down delta x with a dot at this step, because we're working with trig functions which only give you a magnitude. The hypotenuse is 1. Still working with the magnitude. 1 times cosine 60, or just cosine 60. Cosine 60 is exactly 0.5. And again, the trig functions only give you the magnitude. That's why I'm including this dot in. We still don't know what the sign is on delta x. That's our next step to figure out the sign. Well, our x-axis is pointing to the right, and delta x is also pointing to the right. So that's in the positive direction. When we're dealing with the signed component, we show what the sign is, not just if it's negative, but also if it's positive. So if you said the answer was delta x is 0.5, that's really wrong. Delta x is not 0.5. Delta x is plus 0.5. That's really a much better way of expressing the answer. And that's really going to pay off for you when you go on to harder problems, if you get into the habit of always putting a sign in front of a signed component. This doesn't take a sign because it's just a magnitude. The signed component has to have a sign. The opposite side is the hypotenuse times the sine of 60. The opposite side is delta y. But we're working with trig functions, so we're working with magnitudes. The hypotenuse is 1. Sine of 60 on our calculator is 0.87. Well, I guess I'm jumping ahead of the gun a little bit, right? So this is just the magnitude of delta y. Now let's figure out the signed component. Delta y is pointing down, and down is the positive direction. Delta y is pointing down, and down is the positive direction. So delta y is really plus 0.87. I should really include that sign in over here then as well, plus 0.87. This problem should again remind you that the overall displacement, the symbol is delta r, but the symbol for the x displacement is delta x, and the symbol for the y displacement is delta y. This is another problem where I didn't give you the angle at the tail of the overall vector. Instead, I decided to give you the angle at the head of the overall vector. It really made no difference at all, though. As long as we correctly label the opposite and the adjacent sides, it doesn't matter which of these two angles you're working with. And again, as in the last couple of problems, I've been switching up and changing the positive directions. So make sure that you're adjusting and keeping track of the positive directions. You should always write down what the positive directions are. Remember that what I'm writing on the board is the exact notation you should be using in your notes. That includes this notation for the positive directions. You should always write down the positive directions. Always write down the positive directions, and you can use this notation to write down the positive directions. If you've been maybe I should have emphasized that before. All the previous problems that you've done, if you didn't write down the positive directions, are meaningless. It's meaningless to say that it's meaningless to say that v sub x is positive 4 unless you know what the positive direction is. It's meaningless to say that delta y is negative 9 unless you know what the negative direction is. Any problem that you do, you must write down the positive directions. Maybe I should have mentioned that before. Maybe you should go back in your notes and add in all the positive directions. Otherwise, your notes are kind of meaningless. It's meaningless to do a problem unless you actually write down the positive directions for each problem. So again, just as you want to do that just as I've been showing the positive directions on the board.